So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we are following Rising Brain pattern wise DSA sheet and we were doing the very first pattern of array, which was 2-pointer, and today we will solve another problem, container with most water. Most asked and most famous question of the interview. So let's read the problem statement. Problem says you are given an integer array of height, okay, for length n, and there are n vertical lines drawn such that the two endpoints of the ith line are in0 and I height. Okay, so basically we will be given a height integer array and every integer value represents the height of that plank. Okay, find two lines that together with the x-axis from a container such that container contains the most water. So basically your task is to find two different planks or two different heights such that the water between those heights will be maximum. Okay, return the maximum amount of water a container can store, and notice that you may not slant the container. Okay, means you have to store the occupied water. Okay, now let's see the constraint. Constraint says ki you will be given n heights and n can go 10 power 5. Means here brute force approach, if you think for n square will not work. Okay, height also might go for 10 power 4. So as you know that we already discussed ki if n is around 10 power 5, so here n, the length of the array, actually help us to identify how we have to optimize our code, okay, from n square or n log n or n. But height of I, the element value which is 10 power 4 here, it represents ki what is the maximum integral value it can store. If it is more than 10 power 9, then we have to store that in a long form. Okay, so storage is not the problem here, but length of the array might cause the problem if we will solve with n square. Means we have to optimize here in O of n. Okay, so let's come on to the screen. We will be given a height array and every value 1, 8 represents the height of the plank. So here the very first index value is 1. So it represents on x-axis and y-axis ki okay, this is the height of the plank. Okay, and second is 8. So second is 8. So you have to calculate the water these two planks can store in between. Okay, so what is the maximum water it can store? Don't you think the maximum water will be nothing but this area? Correct? Because if you will store more water, that will be flown from left side for sure. Okay, so how we are actually calculating the area? If you see this more closely, we are actually taking the minimum height of both the planks. So we are taking minimum height of what? Suppose we have 2 points, height of left and height of right. So we are actually taking minimum of height of left and height of right. Okay, so whatever will be the minimum height, we are actually going to calculate the area as per that height. And next we want, for area we want width also, correct? Width. And what is the width in this case? Suppose R is this index and left pointer is at this. Okay, so R pointer is here and left pointer is here. Okay, so this is 1 index and this is 0 index. Anyhow, what is the maximum distance between this? The width, and this is 1. You can see here this is 1, correct? 2 minus 1. Correct? So we have to give the width formula by right minus left, because right is first index and left is 0 index. So in total we will get 1. So 1 is the width, and what is the height? Minimum height of 1 and 8 is 1. So in total 1 cross 1 is the water these two planks can store. Correct? So with second and first you calculated the maximum water is 1. Okay. Again with 1 and third you calculated the maximum water is 1 cross 2, because 1 is the minimum height and 2 is the width. So in total 1 cross 2. Again you have to check with 1 and fourth. So don't you think here we have to take the maximum area from first index to all the other planks in the row? Yes. Again from second index to all the other planks in the row? Yes. Then again from third index to all the other planks in the row, and to calculate it we know the formula, minimum of those two heights, and width we will calculate by simple right minus left. Okay, but if we will do this, means our I pointer or left pointer will be here and right pointer will run from I plus left plus 1 to R. This is what we are doing. Yes, so let's move this. What I said, we will run a for loop. This is what we are doing, ki for int left 0 to left less than r n minus 1, correct, and left plus plus. This for loop we will run for left pointer. Again we will run another for int right is equal to, from where we want to run, you can see for this left we want to calculate from another or next pointer. So we have to start with left plus 1, correct, left plus 1, right less than n, and then right plus plus, correct. Now till this we have decided ki one for loop we will take care for the left pointer, another for loop we will take care for right pointer. Okay, so first left will point here and right will point here. Now we want to calculate the area, correct. So this thing we can put here, correct. To calculate the height we will take the minimum of left height and right height. Then to calculate width we can do the subtraction of right minus left, correct. And then after this we can simply calculate ki area will be nothing but height cross width, correct. Yes, it is. Now what is our task? We have calculated the area and we have to return the maximum height of all. So we have to keep a track of what is the maximum height till now, whatever we have discovered. So for that we have to take a max area variable outside the for loop, and this max area we have to keep on updating mat.max for all the area we are encountering now and with the previous area we have encountered earlier. After coming out of these two for loops, we can actually decide ki what is that maximum area, because that will be stored in our maximum area variable. But if you see this more closely, for every left we have run right from left plus 1 to n. For every left means for left is equal to 0, r was 1, 2, 3, 4 till n minus 1. Again for left is equal to 1, r was 2, 3, 4 till n minus 1. Similarly left is equal to 2, r was 3, 4 till n minus 1, and so on. So what do you think? What is the time complexity in this case? First, this for loop, upper for loop for left pointer is running for n number of times or n minus 1, and another for loop is also running from l plus 1 to n, basically n number of times. So in total n cross n. So what is the total time complexity with this approach and this code? Yes, it is O of n square, and as you saw the constraint in the problem was 10 power 5. So if 10 power 5, then n square will go around 10 power 10, means this solution will give you TLE. So what is the optimized way for this then? Whenever we think for any optimized way, we always think about the patterns we have discussed so far. What were those patterns? The very first pattern was 2 pointers, second was sliding window, third was prefix sum, yes, and fourth was cadence. Very good. And we know that these last 3 patterns, sliding window, prefix sum and cadence, we always use whenever we have to take care of continuous subarray, even it is summation, subtraction, threshold value or average, etc. Remember, and all these 4 patterns we have already discussed in our very first lecture of the video. If you have not watched it out yet, I will definitely recommend you to go and watch that very first video so that you can identify which pattern out of these 4 we have to apply here. And we can simply go with the 2 pointer approach here. Why? Because we have to play with 2 different points and then calculate the area between this. Now you will say 2 points and we have to take everything in between. No, it is not like that. We have to take 2 points, and for area we only have to take care of the minimum height and width. We do not need any such elements in between. Any such element means when we are dependent on all the values in between the 2 points and all the values we have to do some calculation, then we can say that this is subarray, correct? But here we need 2 points, and between that we have to calculate the area, and for that we don't need the values present in between this. Remember this, we don't need that values in between. So when we don't need those values, this has nothing to do with subarrays, correct? And when it is not about subarrays, then we can definitely cancel these 3 types of patterns in array, and we can blindly go with 2 pointer approach here. Now what was the 2 pointer approach? 2 pointer approach says your array needs to be sorted, correct? If you remember the point, but here the array is not sorted. But remember why we need that sorted array earlier. so that we can decide which pointer to move, left pointer to move or right pointer to move. But if you see this now here, even if it is not sorted, and if you can decide which pointer to move, left pointer or right pointer, where left pointer always starts from 0th index and right pointer will start from the n-1th index. And if you can decide which pointer to move, even if it is not sorted, basically you are applying the two-pointer concept here. Now let's see, even if it is not sorted, how can we decide it? You know, you can decide. Let's see how. Suppose its height is 2 and its height is 5. Okay, and the distance between is 5 and 2. So we can say the width is 3, correct? We can simply do 5 minus 2, which is nothing but 3. So 3 is the width, and what is the height? 2 and 5. So we will take the minimum height, means according to 2. So we can say this is the amount of water we can store. What? 2 minimum height cross 3 width. So total amount of water is 6. Okay, now after this, what is our task? Our task is to shrink. So whether you are moving from left side or you are shrinking from right side, anyhow the width is going to be smaller. Remember? Okay, width is going to be smaller. And what is the area formula? Length into width. Okay, earlier the length was 2 and width was 3. 2 is nothing but the minimum height between those two planks and W is nothing but the width. Okay. Now I am saying whether you are moving left pointer or right pointer, anyhow the width is going to be small and you want the maximum area. So what do you think? What is that greedy approach you would like to go with? If you want to hold the same area or maximum area, and I am saying your width is going to be decreased. So what do you want? You want to decrease your height or you want to increase your height? Tell me. Yes, you want to increase your height, correct? Because your width is going to be decreased. So if you want the maximum area, you would like to increase your height for sure. So out of those two, what is the maximum height? 5, and you want to keep this, correct? Because in future, you want the maximum area to be calculated with 5. Who knows, what if after 2, you got a maximum height? So if you will lose 5, anyhow the height will be decided by 2 because we always take minimum height. And if in this case, if you lose 2, then the height will be decided by 5 and that will be beneficial. Hence we have decided we have to move that point which are smaller in height, correct? Means we can apply the two-pointer concept here. How? We will initialize our left pointer from 0 and right pointer from n-1. Okay? And because we want to run this right and left, so we have to include or close this in a while left do not cross right, we will run the while loop. Okay, we will run this. Now what we want to calculate? Means our left pointer is here and right pointer is here. So what is the maximum water it can store? Maximum water we can decide with minimum height of these two, which is 1, and the width is nothing but the 9 minus 1. Okay, or if you are taking according to the index, so it will be 8 minus 0. So the width is 8 and the height is 1. Correct? So in this case, what will be the maximum area? So that maximum area we can simply calculate ki height we want to take the minimum of these two. So math dot min of what? Math dot min of what? Height of left pointer, right pointer. Okay. And how we want to calculate width? Width we can simply get by right minus left. Now area, how can we calculate? Area will be height multiplied by width. For sure we can calculate the area, but we have to give the maximum area. So we have to keep a maximum variable also outside there. Yes, we have to. So let's take a maximum area variable saying initially 0 or minus 1. Okay. And now this maximum area we want to update. Why? With maximum area, means maximum area as so far, and with this current maximum area we have got. Ki hey, whatever is the maximum area, save it. Done. Now what? We have actually calculated the maximum area and the water will be nothing but this much. Correct? This much is the maximum water it can store. Correct? Yes. This is the maximum water it can store, and which is nothing but 8 multiplied by 1. Correct? So we can say maximum area as of now is 8, and which is nothing but stored here. Correct? This much water we have stored. Correct. Now we have to decide which pointer to move. Why? Because these were the left and right pointer and we have actually calculated what is the maximum area. And the movement we can decide as per the height. Ki if height of left pointer is smaller or equal to, in case of equal to, remember both, any of the point we can move, left or right. So if height of left is less than equal to height of right, then what to do? Simple, left plus plus. Correct? Yes. Or else what can we do? we can simply do right minus minus, because we want to leave the smaller height and in the future we want to go with the bigger height, correct? So now our left pointer will point to the second index, correct? And now how can we decide the maximum area? Now these are the two heights and we will take the minimum of these two, and here it's 7 and it is 8. So minimum will be 7 and the width will be 7. Why? Because 9 minus 2, which is 7. So maximum area will be 7 cross 7, 49 in this case, and that we will update with the 49. And here is the maximum area. Maximum area will be 7 cross 7. So this is the maximum area of water it can store. Now we would like to move our right pointer behind. Why? Because right pointer is the smaller one. So we will take right pointer behind. And now we have to calculate the area for this height and this height. Similarly, we will get this minimum height 3 and the distance 6. So 6 into 3, 18. So this 49 will not be overwritten because 18 is the smaller one. Now next time, again as this height 3 is minimum, so we will again move the right pointer behind. So it will come to 7 point. Now it will say both heights are same, 8 and 8, but now the width will be 7 minus 2, which is 5. So height will be 8 and width will be 5. So 8 cross 5, which is 40, and in this case 49 is the maximum. Again 49 will not be overwritten. Similarly, we can move any of these left or right pointer because both heights are same. So we have decided we will move from left side. So now this is 3 and this is 8. Again the minimum of 6 height and 8 height is 6. And the distance is nothing but 7 minus 3, 4. So 4 cross 6 means 24. Again 49 will not be overwritten with 24. Now this time this is a smaller, so we will move this height ahead. So this height is 2 and this height is 8. So again minimum height is 2 and the width is 3 because 7 minus 4 is 3. So 3 cross 2, 6. Again the height will not be overwritten. And so on we will do, and maximum height we will get 49 in this case. And what is the time complexity here? You can see we are running a while loop, correct? And we are running until this left crosses right pointer. So basically every point either by left or either by right, we are hitting and reaching by only one time. So in total the time complexity will be O of n. How? Suppose left stopped here till 4, okay? So left started from 1 and reached to till 4, correct? And right started from 9 and right also would have crossed this, na? So right would have covered 9 minus 4, which is 5. So in total left would have covered 4 distance and right would have covered 5 distance. So this while loop will run for n number of times, which is nothing but the time complexity will be O of n. So this is the optimized code as well. So let's code it in our code editor now. So now let's code. Here is the problem statement we have already discussed. So we first need the n length. So for n we can write n is equal to its height here. So height dot length, correct? Now we want two pointer, left pointer and right pointer. So we will initialize left pointer with 0 and right pointer with n minus 1 basically. Yes. Now to store the maximum area, we want an integer value. So max area we will consider this with 0 only because that is the maximum area it can hold, correct? Now we have to run the while loop for left and right. We can write the equal to operator also. Why? Because when both right and left is pointing to the same, we cannot calculate the distance, correct? So we will write equal to, because we have to calculate the maximum area between two numbers, na? And when both left and right will point to the same number, means how can we calculate the area? Because for area we need two different points. So that is why we want to stop this even if left and right pointing to the same index. Okay, now our task is to calculate the height. So we can store the height in math.min for height of left and right, because we will take what is the minimum height out of those, and then we will save in width. That width we can simply calculate by right minus left. Area we can simply do height into width. And now our task is to update our max area. So that max area we can simply update with math.max, max area so far and the current area. Okay, now we have calculated the maximum area and updated also. Our task is to choose which pointer to move, left or right, and that we just saw that we will decide which is the minimum one. So we will see if height of left pointer is less than height of right pointer equal to also. If this is smaller, we will simply do left plus plus, else we will do right minus minus, correct? And after the while loop, we can simply return our max area which we have calculated. Let's run this code. Sorry, this was right minus left, my bad. Okay, and we can submit this also. Let's submit. So we can see our code is submitted. Similarly, we have done this with the same logic. We have submitted the code in Python. And here is the code for C++. If you are from C++ background, we have discussed the logic is same, and these are the 3 different language code which we have provided. So with this, we can mark the container with most water as well from this Rising Brain sheet. And if you don't know about this sheet, we have made the DSA sheet as per the pattern wise, and we are covering the 2-pointer pattern here, and we have submitted the one more question from this pattern. And if you don't have the sheet link, you can simply check it out from the comment section. And to connect with me on Instagram, LinkedIn and Twitter, all the connection requests are in the caption below. Do connect for the latest updates. So that's all guys. I hope you have learned something new from this video. And if you feel the idea of solving all the problems, that too pattern wise, is really helpful, then don't hesitate to subscribe and follow with your friend, because that gives me more motivation to make more videos for you all. You can also check our playlist where we have discussed about different patterns of all the data structure, and after discussing all those, we have started solving questions on the pattern wise. I hope that will be helpful. That's it for today's video. Let's meet in another video with some more interesting topic and questions. Till then, keep learning, take care of yourself and your family too.